Hello, this is Jessica Morse, and this is my presentation on sections 13 through 15 of Chapter 18 of Organic Chemistry. Chapter 18 deals with the compound of benzene, and these sections discuss nomenclature of substituted benzene, as well as the effect the substituents have on reactivity and orientation. First, we will discuss the nomenclature of substituted benzene rings. In the first section of the chapter, nomenclature for monosubstituted benzene was discussed. For disubstituted benzene, the prefixes ortho, meta, and para indicate the relative positions of the attached substituents. Ortho describes substituents placed on adjacent carbons. Meta describes substituents placed on carbons 1 and 3. And para describes substituents placed on opposite carbons. On the right is an example of an ortho ortho-dibromobenzene. And the compound can also be called 1,2-dibromobenzene. We continue on with more rules for when disubstituted benzenes get a bit more complicated. When the substituents are different, they are listed alphabetically with their assigned numbers preceding. So the example to the left has bromo before chloro because B, of course, comes before C. As expected, the first mentioned substituent is given the 1 position and the second substituent is given the lowest possible number. So with the example to the left, bromo, which is first, is assigned the number 1 and chloro is assigned a 3. For polysubstituted benzenes, that is benzenes with 3 or more attached functional groups, the substituents are numbered in the direction that results in the lowest possible numbers. Also, the substituents are listed in alphabetical order. This means their preceding numbers aren't necessarily in order. The example on the left is 4-bromo, 2-ethyl, 1-nitrobenzene. The substituents are alphabetical. The example on the right shows the nomenclature for compounds with substituents that have names which can be incorporated into the root word for the compound. The OH group makes the benzene a phenol and is given the 1 position. The other substituents are assigned the lowest possible numbers and are listed alphabetically to create 5-bromo, 2-chlorophenol. The presence of a substituent of benzene affects its reactivity. Like benzene, substituted benzene can undergo the 5 electrophilic aromatic substitution reactions discussed in previous sections: halogenation, nitration, sulfonation, and Friedel-Crafts acylation and alkylation. We will discuss if and how the substituted benzene will be more or less reactive towards these electrophilic aromatic substitution reactions. Substituents that donate electrons, thus making benzene more nucleophilic and more attractive to electrophiles, are known as activating substituents, while substituents that withdraw electrons, thus making benzene less nucleophilic and less attractive to electrophiles, are known as deactivating substituents. The figure shows that the presence of an electron donating substituent increases the reactivity relative to benzene, while the presence of an electron withdrawing substituent decreases the reactivity. In this figure, the X substituent donates electrons to the benzene ring, which makes it negatively charged. And this stabilizes the carbocation intermediate, which is positively charged, which activates the ring and increases reactivity. A methyl group, for example, activates the ring by donating electrons. The Y substituent, however, withdraws electrons from the benzene ring, which is positively charged, and destabilizes the carbocation intermediate, which is also positively charged. This deactivates the ring. A trifluoromethyl group, for example, deactivates the ring by withdrawing electrons. This slide summarizes the relative reactivities of benzene rings with these various substituents attached. The substituents to the right of H, which is the standard for comparison, activates benzene and makes it more reactive. These substituents are electron withdrawing and generally have a negative charge. The substituents to the left of hydrogen deactivate benzene and make it less reactive, and these substituents are electron withdrawing. When a substituted benzene undergoes an electrophilic aromatic substitution reaction, the placement of the incoming substituent depends on the first substituent attached. The product will be the ortho, meta, or para isomer. Activating substituents, or weakly deactivating halogens, are ortho-para directors and will form both the ortho and para isomers. Substituents more deactivating than the halogens are meta directors and will form the meta isomer. The substituent shown on the reactant is an activating substituent or a weakly deactivating halogen and is an ortho-para director. The major products of this reaction are, of course, the ortho and para isomers. An example of ortho-para directors are listed below. And the substituent shown on the reactant of this slide is a substituent more deactivating than the halogens and is a meta director. The major products for this reaction, or the major product for this reaction is, of course, the meta isomer. And again, the examples of meta directors are listed below. This concludes my presentation. I hope you enjoyed.